Hello, New York. Thanks for being here. I thought I would mix things up a little bit and talk about agents for a change. That's okay with everyone? So it's obviously a very hot topic for us at Vercel. And earlier today, you heard Tomo talk about Eve, our framework for building agents. From Gene, you heard about how we have 100 agents in production. And you also heard about the most popular of those agents, the one nearest and dearest to my heart, D0, our data science agent. Now, D0, Vercel has about 800 employees here at Vercel, and D0 answers over 30,000 questions every month for those employees. And I love that stat. I say it all the time, but it's not my favorite stat. This is 45% of those questions aren't from humans. They're from the enterprise apps and agents you heard Gene talk about earlier today. Now, D0 has been so successful for us over the past few months that we've taken the show on the road. We've gone to some of the most inspirational companies we know. We've taken Eve, we've taken our learnings from D0 and helped them add their context, their creativity, their tools to build data agents of their own. And now, we have a lot to learn from them. One of those companies is New York City's very own Clay. Clay built Monty, their data agent. Monty is in production today, and it saves the Clay data team 40 human hours every day. And they built it with one engineer in under a month. I have one goal for today. I want to see 1,000 new data agents in the wild. We built one, Clay built one, you can too, and you should. I want every company in this room to build your own D0. And transparently, this is also a little selfish. I want D0 to be the best it can possibly be, and I'm convinced that the way that happens is by watching to see what you build. So I'm gonna do two things today. One, I'm gonna show you a little bit high level about how we build these agents, what's common across everyone that we've built, everyone that we've seen, what's different. And second, why you should be building these on your own and not buying them off the shelf. So let's get started. So over the past few months, as we've helped build, as we've watched dozens of these data agents take flight, across all of them, we've seen a common shape of what we think of as a minimum lovable data agent. In particular, we see these 5 things. First, minimum lovable data agents meet users where they are. That means they need to be available in messaging tools. For us, that's Slack. For other people, that's Microsoft Teams, but not just those tools. When users ask sensitive questions that can't be answered publicly, D0 can't just answer in Slack. It needs a web UI. When users want to create and interact with charts and dashboards, they likewise need a web UI. When someone wants to call a data agent from Claude Code or Codex like they do every day, they need an MCP server. When they want to call it from an application, they need an HTTP API. And when other agents, as you heard increasingly for us, are calling our data agents, they need an agent-to-agent interface. Truly lovable data agents need to support all of these services. 2, lovable data agents need to navigate rich context. This is the whole game. They need to understand your business. They need to understand what your metrics are, what your terms mean, how your company works, and they need to pull all that context in at the right time into the right workflows. 3, lovable data agents need to query data and take actions. Well, this is the obvious one, but it's not that simple. Because to really be able to answer any question, data agents need to be able to connect to any of your data sources, not just the biggest one, not just a singular data warehouse. And to be able to take any action, data agents need to be able to connect to all of your systems of action. And all of those connections have to be secure. The agent can never leak your credentials, not even to the LLM. And every connection has to respect permissions. Your agent should only be able to see and do what its human counterpart can see and do. 4, lovable data agents need to follow analytical playbooks. Across these 30,000 questions a month, we find that most questions are non-novel. They have a pattern, they repeat, they can be templatized, and the agent needs to know what those patterns are and follow them. 5, lovable agents need to execute recurring work. Again, across those 30,000 questions, we see that the most important questions are not one-offs, they are recurring. Every Monday, your agent needs to pull key metrics. Every day, your agent needs to check customer health and flag warnings. Every month, your agent needs to analyze marketing ROI. True lovable agents have routines. Now, for both D0 and Monty, it was actually easy to express these capabilities because we built on Eve. We designed Eve for agents like this very explicitly. Eve treats agents as a file system, and the structure of that file system means that every capability, these 5 capabilities we talked about, has a natural home with all the functionality we need for that capability to be complete. When we needed D0 to support multiple surfaces, we just declared those surfaces as first-class Eve channels. Now it's the exact same D0 in Slack, in a web UI, behind an HTTP API, and as an MCP server. It's one core with many surfaces. When we needed D0 to securely connect to systems of data and systems of action, we just drop new tools in the tools folder. Execute Snowflake query, execute ClickHouse query, update Salesforce. The model backing the agent only ever sees the tool, never the credentials, and because we wire those tools to OAuth with Vercel Connect, every query assumes the roles and permissions of its human user. When we needed D0 to follow playbooks, we just wrote them up as skills, and we dropped them in the skills folder. And because skills are just English, anyone can author playbooks, either as dynamic skills just for themselves or global skills available to everyone in the company. And when we needed D0 to do recurring work, we just wrote another plain English prompt. We add a cron condition, we drop it in the schedules folder, and that prompt gets invoked on a schedule, and D0 responds as if it were invoked live. But what about context? Now, the simple answer is that context also has a natural home in Eve, and it's right there in that sandbox folder. For us, context, once it's in the sandbox, becomes a part of D0's navigable file system, so D0 can now use bash like a coding agent, or any structured retrieval tools that we provide it. But the more interesting answer is how we think about context, because again, for these agents in particular, and agents writ large, context is ultimately all that matters. For us, we went the route of being highly structured. We have over a dozen types of very structured context, most of which are represented in YAML, and 5 of those are the most important. 1, our semantic layer. This is essentially a catalog of every single table in our warehouse, the fields it contains, the business logic that can be derived, the valid aggregations that an agent can perform. And again, YAML. 2, our metrics layer. This layer takes the aggregations we define in the semantic layer and reifies actual business metrics. 3, our events layer. Every day, we scrape our changelog, we scrape our sales plays, our marketing campaigns, our outages, any data pipeline alerts, and we create a structured event stream. 4, our terminology layer. These are our glossary terms. They express how Vercel talks about Vercel, include aliases and synonyms and related concepts. And 5, our guides layer. These are plain English essays written by data experts and domain experts to teach both humans and agents how Vercel works. This is very rich context, and it's also very structured context, which means, in our case, because again, a lot of these are YAML, we can give our agent structured retrieval tools and not just bash. Bash takes you very far. It's not all you need. Now, this is a lot of work, but we think it's the key to D0 success. Now, next up, I want to give you a different perspective. I'm going to bring up our friends at Clay. Their data agent, Monty, was inspired by D0. It's built on Eve, and it works very similarly, but it's also genuinely different. Monty is Monty, not a D0 clone. So joining me now is the lead of Clay's data team, Josh Hanson.
Thanks, Abhi. We've had a lot of fun building Monty, and I'm excited to share what we've learned. I'm going to pick up where Abhi left off and walk through how Monty works and the unique decisions we made in building it. I want to start where Abhi ended, specifically with navigating context. Abhi mentioned that D0 has a rich, structured context layer. We took a slightly different approach, and this was the biggest design bet we made. At the start of every session, Monty clones our entire data team repo into its file system. That repo is the brain. DBT models, the semantic layer, metric definitions, team skills, dashboards, notebook analyses, years of how the Clay data team thinks about Clay's data. This is a different approach, and we picked it because we were trying to get away from the classic semantic layer pattern. Semantic layers promise to tell the LLM exactly which tables it can query, by which measures, across which segments. They promise governance, but the reality is you've taken an incredibly powerful reasoning engine and reduced it to an expensive SQL generator. We bet the other way. Modern models can reason across almost any problem if you give them the right context. So instead of a fixed menu of allowed cuts, we give Monty all the raw context it could possibly need, and we trust it to pick the right tools for the question. Here's how that works in practice. Monty has a navigation map in its system prompt. Every folder in our repo has a tiny catalog, a one-line index of what's inside. Monty scans that catalog, finds the one or two entries that matter, and opens only those. The big three Monty leans on most are, first, skills, which are the team playbooks with triggers and recipes and gotchas. Two, plain English model documentation covering about 100 governed models. And three, our raw DBT SQL, which Monty only opens when it really needs to see how a column gets computed. 3 levels of progressive disclosure applied across an entire repo. But here's the thing I really want to plant in your head, because I think this is the bigger story. Everything analytical at Clay lives as plain text in GitHub. Transformations are SQL, column docs are YAML, metrics, skills, team context, they're all Markdown, dashboards and notebooks, all Python. When an analytics engineer ships a model, Monty knows about it on the next session. When a data scientist pushes a new notebook, same thing. When someone codifies a new metric, same thing. Nobody on our team maintains an AI knowledge base. Our code base is the AI knowledge base. The work the data team is already doing is the work that's making Monty smarter. Okay, so that's how Monty knows where to look. Let me show you what it does with what it finds. Monty's toolkit is intentionally small. Monty has read-only access to Snowflake, locked down, row-capped, every query tagged for audit. It also has a Python sandbox where it can run pandas, stats models, scikit-learn, fits models, plots things, push charts back to Slack. It also has access to the Clay API, which allows us to connect and manage our Clay instance. And it also has what we call an analytical constitution. Guardrails written into the prompt. Things like correlation isn't causation, always pair rates with its absolute count, flag small samples. This is all the stuff that kind of keeps Monty honest. This toolkit plays off in 2 situations in particular. The first is a metric lookup that doesn't dead end. When someone in Slack asks, what's our X metric and how is it trending? And immediately wants to know why, which segments, which workspaces, which users, Monty can answer the metric question from the metric layer, then walk down our entire DBT lineage to the workspace grain facts and re-answer from there. The second is repeatable work. That looks ad hoc, but isn't. Think renewal prep deep dives, account health reviews, pipeline reviews. They all have a shape. They can all be templated. We codify that shape as a skill, and Monty runs that workflow at the data team's quality bar. I want to show you the second one because I think it's the most illustrative. This is a real Slack thread, lightly scrubbed. It hit our channel 5 a.m. one morning. Someone said, I believe customer X is coming up for a renewal. Can you do an account health deep dive? And Monty's first words back were, let me start by checking for the right skill to follow. And then it goes, end to end, 15 tool calls, 6 governed queries, 1 matplotlib chart, 0 errors, 2 minutes, 12 seconds. What it actually did, it read our skill catalog, matched the EGS account health skill, read the skill's 2 reference docs, 1 for gotchas, 1 for our pricing cutover, pulled the account from Snowflake, worked through the playbook's models, built a burn down chart in matplotlib, and posted it all back to the thread. 1 skill rooted the entire thing. But here's the part I really want you to see. The skill we wrote bakes in a warning. It literally says, don't let healthy pacing fool you. And Monty caught it. The headline numbers on this account looked great. They burned 86% of their credits within 91% of their contract term elapsed, right on pace. That lands the credit pool right at renewal. But the skill told Monty to keep digging. So Monty pulled the rolling 30-day consumption and it had dropped. The March peak was 1.5 million credits spent a day. Today, it was 220,000, nearly down 33%. Then, Monty looked at who's actually using the account. 5 logged in users in the last 30 days, 2 builders driving most of the spend. And then it did one more check. The account numbers one historical user, the person who originally built the use case, hadn't logged in for 188 days. So here's what was actually happening on this account. A rosy number was hiding a softening account. The skill warned about it. Monty caught it, and the CSM had the right read at 5 a.m., all before anyone's first meeting. And this is exactly what we mean by giving everyone the analyst playbook. We write the playbook down once, and Monty runs it the way an analyst would. That's a small peek at how Monty works. We can't wait for it to transform Clay. In a lot of ways, it already has. And back to you, Abhi.
Thanks, Josh. Okay, so 2 data agents, same framework, Eve, 2 very different companies, 2 very different agents. And that gets us to the second thing I promised, why you should build your own and not buy these agents off the shelf. Here's how I think about it. Both data agents you saw today connect to 4 kinds of systems. First, systems of data. This is where your data actually lives. Second, systems of context. These are the systems that organize the architecture of context around that data, that give it meaning. Third, systems of action. These are other business systems where the agents go to do work. And fourth, systems of interaction, where the agents go to meet people. The punchline is, no vendor, I promise, can ship all 4 for you. And that's because every one of these systems is different at every company. Your data stack is yours. Your context layer is yours. Your action systems are yours. Your interaction systems are yours. And off-the-shelf agents can connect to some of these, but they will never, never ship the specific combination of these 4 systems that your company actually runs on, and they'll never be able to express your context the way your company needs and is deemed optimal. Agents as a service providers can ship an agent, but they can't ship your agent. Now, again, I started this talk by saying I wanted to see you all build the next 1,000 agents, and I meant it. D0 has changed how Vercel operates, full stop. Monty is changing how Clay operates, and we're watching a dozen more being built right now. Every one of them is unique, every one of them is theirs, and we hope you build yours, and we want D0 to learn from yours. If I can be helpful, please reach out. Thank you.